Hey friends, welcome back to our channel. Today we are going to discuss about Karpenter in the context of AWS EKS. So we will understand what is Karpenter, what is it benefit with the cluster autoscaler, and what is the architecture. So let's get started. So what is Karpenter? Karpenter is actually a node provisioner. Its job is to add nodes to handle unscheduled pod and schedule the pod on those nodes and remove the nodes when they are not needed. What is the advantage of using Karpenter over cluster autoscaler? So it will optimize the resource utilization. So that is the most important thing. It can do this by automatically provisioning the node based on the application need. This means you can avoid over provisioning, which can lead to the wasted resource and increase the cost. So let's, for an example, you have a pod request and you need two CPUs. And when in the case of cluster autoscaler, it may provision a 6 CPU resource based on your autoscaler configuration. And then the 4 CPUs are actually wasted and you need to pay for that money. But when it comes to the Karpenter will analyze the node request, the pod configuration and identify the resource requirement from the deployment.yaml file and identify the suitable resource or suitable node from the AWS cluster of EC2 instance, and then provision that node and then create that pod in that particular node. So it is basically optimizing the resource in that way. Second is a cost saving. So of course, when you are creating a node which is suitable for that particular pod resource request, then you are not wasting any resources. Thus, you are not wasting any money. So that is a cost saving. Then ease of use. Karpenter is really easy to install. You can use the Helm and you can configure that. We'll go to the architecture and the configuration. Compared to the cluster autoscaler. Cluster autoscaler is run based on our AWS autoscaling concept, and it is little bit difficult to manage compared to the Karpenter. So let's check what is the difference between cluster autoscaler and the Karpenter and why we use Karpenter. Cluster autoscaler basically actually using our AWS autoscaling concept, and it is built on top of the AWS autoscaler. So it's use its own launch template, identify the instance and provision the instance. There is not much intelligence built on top of that one. Okay, say for an example, you need a pod and when the pod is pending because of that the cluster is not having enough resources. So the cluster autoscaler will identify that and it will ask the autoscaler to create a node. Okay, autoscaler will check the launch template and identify the configuration from the launch template and create an instance. And then what will happen is so the Kubernetes will schedule or EKS will schedule that particular pod onto that particular instance. That's how the node will create and the pod will create on that particular or schedule on a particular node. But in the case of Karpenter, it's again starting with the same pod which is on pending status. The Karpenter will identify there is a pod which is pending. It will analyze the resource request utilization or resource request, and it will ask the Karpenter node pool and node class. We'll come to that one later, but it will ask the Karpenter node pool to create a node based on the resource requested by the pod. So it will identify the best EC2 instance and create the node and provision that particular pod into that one. So this is how in the case of in the case of Karpenter, the Kubernetes cluster pod scheduling is actually happening. If you check here, you can have multiple EC2 instance type. You can have M-file, large, C is compute optimized instances, CPU optimized instances. You can have storage optimized instances. Based on the resource request, the Karpenter will automatically identify the best instance type and it will provision that one. That is how the Karpenter win against autoscaler. Let's identify what are the different components of the Karpenter. So Karpenter has basically two main components. So one is the node pool and another is the node class. So what is actually a node pool? Node pool is actually a custom resource that create and manage and delete the nodes on the Kubernetes cluster. It set a constraint on the node that can be created by the Karpenter and the pod that can run on those nodes. It's defined the EC2 type, like which type of EC2 instance, memory optimized, general purpose, compute optimized. So what kind of instances needs to be run. So we are configuring what kind of instance category which you need to select when there is a request for a port comes up. And in this case, in the node pool itself, we are configuring the capacity of this EC2 instance. So whether you want on-demand instances, you can have spot instances, and again on the node pool, you are even saying which availability zone you need to configure this the node pool. So based on these details, this configuration, Carpenter will identify the best resource and create the pod on that one. So node class is actually adding AWS components on top of the node pool which was created. So it's assigning IAM role to the EC2 instances. It is adding security group. It is adding user data into the nodes. So the node pool is actually having a connection with the node class. So the node class can be added to one or more node pool, and the node pool will have a section called spec.node class reference. There you define the node class name. So that's how the node pool and the node class is connected. By the way, version before version 0.33, instead of node pool, there was another component called provisioner. So the provisioner, it's almost the same thing, but Carpenter added more features like user data script, security group, and all those things by introducing the node class and the node pool. So apart from this main two component, there is little more on Carpenter. So let's verify that one also. So Carpenter is actually doing the scheduling work. Okay, so when you are scheduling the resources, it is based on the resource request. It's based on the node selection criteria. It is based on the node affinity and or anti-affinity thing. So that is actually the scheduling part. So it is actually also taking care of the disruption. So for second example, when your the requirement is completed, or your auto scaling is completed, now you wanted to reduce the number of pod, and the Carpenter will identify there are free nodes available now, and what it will do is it will reshuffle the cluster and cluster nodes or the pods, and it will check and identify if it can free up some of the nodes. If there is a provision to free up the node, it will free up that particular, it will take the or deprovision the pod from that particular node and create those pod in a different nodes, and then it will free up that particular node altogether. So that's how you are actually saving the cost as well there. So how the disruption is actually working. So what is actually happening is when you are creating a node through Carpenter, Carpenter is actually creating a finalizer object on that on the node. So when a request comes to delete one of the node, or in case if it is its TTL is over, or you are running a kubectl delete node, Carpenter will cordon the node and drain all the pod and terminate the EC2 instance and delete the node object. Carpenter handle all the cleanup work as well. So some scenarios where this disruption will occur is actually expiration. So you can set expiration time in the spec disruption dot expire after property. So based on that one, Carpenter will mark the node as expired and disrupt them after they have lived a set number of time. You can use this expiry periodically to recycle the node because of security reasons and all. And another one is consolidation. Carpenter will work actively reduce the cluster cost by identifying when a node can be removed because node is empty. A node can be removed as the workload run in another node in the cluster, or node can be replaced with a cheaper variant. So another important thing is interruption. So Carpenter will watch for upcoming interruptions, even that can be affected by the node health or even spot interruptions, and will cordon and drain terminate the nodes ahead of even to reduce the workload disruption. So that's all about the Carpenter. The important thing which you need to understand is Carpenter is nothing but a node scheduler. It will create, delete, and manage the nodes. So it is much faster, very cost effective, easy to maintain. That's all about Carpenter. If you like this video, please consider subscribing the channel. Thank you so much.